subscribe and press this bell icon to never miss another lecture video. We are in lecture number 67 of Signals and System, and here we are still in the module of Fourier transform, and we are still going through the Fourier transform of continuous time signals. But this lecture video is a very important lecture video for your GATE exam, because here we are going to analyze and give you formulas, and also we're going to discuss couple of very important questionnaires and question types regarding different kinds of pulses. It might be a rectangular pulse, it might be a triangular pulse, it might be a Sinc pulse. Oh my god, this is so beautiful. Okay. Or it could be a impulse, train of impulses, or it could be a Gaussian pulse. What will be the subsequent Fourier transform of those pulses, and various questions and the note points or formulas which are associated with those questions. All of these things we're going to discuss here in this video lecture, so do not skip a single minute from this video. Okay, now let's start with the first thing I need to tell you. Just go through like blindly now. Whatever things that I'm going to tell you, just take it blindly. Okay, then after that we'll get into the analysis part. You're being asked ki what is the Fourier transform of a rectangular pulse. The rectangular pulse, the Fourier transform of a rectangular pulse will nothing but a Sinc function or Sinc pulse. What is the Fourier transform of a triangular? That will be nothing but a Sinc square function. Okay, there will be no negative part here. Okay, what will be the Fourier transform of a Sinc function? That will be nothing but a rectangular function. Okay, what is the Fourier transform of a Gaussian pulse? Gaussian pulse Fourier transform will be a same Gaussian pulse. And what is the Fourier transform of a train of impulses? That will be the same train of impulses. So please remember, Fourier transform for Gaussian pulse is a Gaussian pulse. Fourier transform of a impulse train is the same impulse train. Fourier transform for a rectangular pulse is a Sinc pulse. If you have a rectangular pulse, then the Fourier transform is a Sinc pulse, Sinc function, and vice versa. Vice versa means if you take a Sinc function, the Fourier transform of this Sinc function will nothing but a square or rectangular pulse. Okay, triangular pulse, if you take a triangular pulse, the Fourier transform will be a squared Sinc pulse. And if you take a constant, a, the Fourier transform will be a impulse function. Yes or no? And vice versa, if you take an impulse function, the if you take a impulse function, the Fourier transform will be a constant. If you take a impulse function, the Fourier transform will be a constant. So vice versa is also true. So vice versa, in place of vice versa, I made here a pink color ka arrow mark. Now let's get into a little bit deeper. But before getting too deeper, I'm not going to analyze a lot of formula based things or analysis and the derivation of this formula. I'm just going to give you the overall formulas and their small point of views. I'm not going to describe each and everything to you. You just need to remember those specific things for GATE exam. That much amount of information that I'm going to share with you. Now listen to this carefully. This is your rectangular pulse, looks beautifully like having a width which is being dedicated between minus t/2 to t/2. Now to find out the Fourier transform, we know, sir, Fourier transform is a Sinc function. We know this. Now what will be the mathematical representation of the Sinc function? That formula is this. So you need to find out the area of this rectangular pulse. Sir, t/2, sir, length into breadth, sir, t/2 into t, into 2, sir, this length is t, sir, this length is t, into what is the breadth here? So breadth is sir 1, sir, absolutely correct. So what is the area here? So area is t, sir, and Sinc. What is the domain that you are going to present? That is frequency domain. So you need to put your frequency domain value w here into the component that will going to be get multiplied over here is width by 2. What is the width? What is the width by 2? What is the width is here? What is the width here? What is the width here? That is t. The width is, please don't go with my language. Please try to understand the concept. I know I'm buffling right now, but please do not go with my pronunciation. Just stick to the concept. Just अपने फायदे में रहो आप. Just concept grab करो और चलते बनो. If you are still finding this lecture is to be slow, there is this 3 dot buttons is there in YouTube. You just press it and you'll get 1.25 speed or 1.50 speed and make it faster. Okay. If your width is a t here, if your width is t here, so it will be t by 2. Now the sinc function that you are going to get, the Fourier transform of this particular rectangular pulse is nothing but t into sinc of t by 2 into omega, this value. Similarly, for a triangular, the formula is this. So what is the area, sir? Half into base, sir, 2t into height, sir, 1, sir. So this will be t only, sir. Absolutely correct. T into sinc of domain is w domain, this is frequency domain, into width by 4. What is the width? What is the width? What is the width? What is the width, sir? That is 2t, sir. The width is 2t. Yes or no? So 2t by 4, sir. Absolutely correct. That means t by 2. Correct. Now iska whole square, that means sinc square. You can say sinc square omega t by 2. Clear with this concept? It is a very simple thing, but it will complicate you like hell. So please stick to the note points or stick to the formula that I'm providing to you. Just इतना ही पढ़ना है, इससे ज़्यादा नहीं पढ़ना है. ठीक है? So the equation for this thing is nothing but this: t sinc square into t by 2 into omega. Similarly, if you have here there is a very important point you need to remember here: how to write an equation for a sinc pulse. I'm not getting into the detailed analysis of mathematics. I'm just going to give you a shortcut. Okay, that shortcut that you need to follow. I'm just really going very bad with the pronunciation. I'm really sorry with that. Now if you have a sinc function, the coordinate here is minus 2 pi by 2, the coordinate here is plus 2 pi by 2, then please remember, so first you need to write down it is a sinc function. Okay, it is a sinc function. What is the domain here? It is time domain. Obviously it is time domain, so there will be a t term over here, there will be t term over here, there must be some multiplied factor over here, and there must be some multiplied factor over here. What is the multiplied factor over here? The magnitude, that is nothing but omega naught by 2 pi. Now what is the multiplied factor with t? What is the multiplied factor with t? Please remember this thing. Always look for the first place where the sinc function is intersect with x axis. First, always remember what is the first point. That point is 2 pi by omega naught. That means what is the denominator of pi? What is the denominator of pi? If it is a 2 pi by omega naught expression, what is in the denominator of pi? That is omega naught by 2. This omega naught by 2, it is the main point of discussion. This value you need to find out from this expression. So this value, this multiplication factor will be omega naught by 2. How you get this omega naught by 2? You need to find out the denominator of pi. Okay, now once you, this is the entire expression for your this function. This is your entire expression for this sinc function. You got this point, how to write a mathematical form of the sinc function. There is a lot of analysis are there. I'm not getting into the mathematical format and the analysis. I'm just giving you a overall like ऊपर से simple सा method मैं आपको बता रहा हूँ. Look here, and this omega naught by 2 is nothing but the, obviously it is a sinc function. That means the Fourier transform will definitely going to give you a rectangular pulse, but the width, in order to get the width you need to find out this value. This value is nothing but your omega naught by 2 only. You got this idea? So you only need to find out. So magnitude you got from this value. Okay, you get your magnitude value from here. It's simple, but in order to get this value you need to look for what is the denominator part of this pi. Okay, just look for it in the maximum question. You can find it out like by looking at this graph. You can write the expression, and once you write the expression, you can write the expression for the rectangular function as well. Okay, moving on to the next point. If you have a Gaussian pulse like this, it will be this kind of expression. We know this is the standard format of a Gaussian pulse. We'll get into detail analysis on this Gaussian pulse and its derivation in communication subject, analog communication subject. The Fourier transform of this function will be nothing but root pi by a into e to the power, that format only. This thing is in that format only, minus 1 by 2a ka whole square into omega square. So this is your omega domain, that is frequency domain. This is your t domain. Yes or no? Clear? Similarly, we have discussed about this thing. Two things we have discussed here. Remember, two things that we have discussed. First thing, the Fourier transform of a train of impulses is nothing but a train of impulses, and also Fourier transform of a periodic signals. What will be the value? Each and every pulses will be represented at its proper harmonic impulses, that what it is presented in the time domain. The same thing that we have discussed in a Fourier transform of a periodic signal wale chapter mein. Now moving on to the next slide, here we are going to discuss about couple of examples which we have just discussed. The first example will be nothing but to find out Fourier transform, find out the Fourier transform, find the Fourier transform. Okay, now let's find out the Fourier transform of this thing. Is the formula is area into Sinc. Obviously it will be a Sinc function. Sinc into Fourier transform means this will be in a frequency domain, so there will be a frequency component here, into there must be a multiplication factor. That multiplication factor will be nothing but width by 2. So this W and this W is different. This W is frequency, your angular frequency, and this W is width by 2. Clear? So what is the area? Area is t by 2 into 2 into 1, that is nothing but t. So area is t into Sinc of width by 2. Width by 2 is t by 2 into omega. This is your Fourier transform of this function. Clear? What is the Fourier transform of this function? Similarly, you need to find out the area. I want you to find it out. Area, what is the area? 7 by 5. What is this length? 2 into 7 by 5 into 10 by 21, which will be nothing but how much? 140 by 105, I think. This is your area value, and this is what is the area is, and the function that is width by 2. Width by 2, that will be nothing but 7 by 5 only. So you will get your Sinc value, your Fourier transform will be 4 by 3 into Sinc into 7 by 5 into omega. Clear with this concept? The Fourier transform of this expression is as simple as that. Now let's get into a little bit tweak. This is a very interesting question. I just draw it in a different color so that you can have a very good clarity. It is saying that this is f of t. This is f of t. Now find the f of omega. Find the Fourier transform of this f of t. Now in order to solve this question, I divided these two graphs. This wala graph, and this wala graph. I have just divided these two graphs. Into two different way. First is 4 to 10 this graph, and another this graph is in this format. Now what you need to do after dividing these two graphs in this way, you need to shift them in our proper standard format. I forgot to tell you, I'm really sorry, forgot to tell you, this formula is only applicable if you take all of your pulses, triangular or rectangular or whatever the pulses is there, into the standard format, like in this origin only, then only this formula will going to work. So this formula is very easy to find out. The first way of doing calculation of this entire rectangular function, the finding out the Fourier transform of this entire rectangular function is really difficult. Do it by yourself, then you will understand. So this is a very nice way to solve this thing. The first thing that you need to do, you need to shift this. So first you got this is the function and this is the function, right? By adding these two function, you're going to get this function. Now you need to divide these two function and to make it a proper way so that we can make that formula, or we can convert that formula. I'm really sorry I'm boring you, but this is the only way that we can do it, and this is the only way that I can make you understand. So once you shift it into a origin path, and once you shift it into your origin, so after doing this, you just name it, it is f1t plus 5. Obviously if it is f1t, this is f1t and this is f2t. okay, now this is your f1t plus 5 and this is f2t plus 5. I shifted it, I delayed it, right? I'm sorry, I advanced it. I'm sorry, I advanced it. So you need to advance this function in order to find the origin best, or we can apply the formula now. Now it's very simple. Now f1t plus 5 time shifting property of Fourier transform, that will be nothing but f1 omega into e to the power j omega 5. f2t plus 5 will be nothing but f2 omega into e to the power j omega 5. Now what is f1 omega? f1 omega will be 40 sinc omega, 5 into omega into e to the power, the normal e to the power j omega 5. e to the power j omega 5 will be there. 40 means this is the area of this rectangular function. Sinc of 5 of omega, I'm sorry, this one is plus 5, no? Yes, I'm really sorry. So 5 omega, that is width by 2, right? So 10 by 2, that is 5 omega. Now similarly for this thing, you can also write down the equation, that will be nothing but 3. The area will be, the area will be 8 into, obviously 4 into 2. I'm really sorry. 4 into 2, that will be 8 into sinc of width by 2, that is 1 into omega, that is omega whole into e to the power j omega 5. Clear? Now the entire Fourier transform will be the addition of these two, because Fourier transform does obey linear property. 40 sinc 5 omega plus 8 sinc omega. Clear? This is your answer. This is the best way of solving this kind of question quickly. Now moving on to the next kind of question, it is very important. This is a triangular function. The formula is area into sinc square omega into, width by 4 into omega. I want you to find it out, the answer. It's very simple. The answer will come out to be 3 into sinc square into 3 omega by 2. This will be the Fourier transform of this function. Now this is very important question. Do not do it in this way, the way that I did. No, just do the shifting and do this way and find out the time shifting method. Don't do it in this way. Don't shift it and then put it like f1t plus 5 or something. Don't do it this way. This is a horrible way of doing it. The answer will come out to be wrong. So if there is a triangular function, first take the standard form, take it out, like just convert it into the standard form, that is take it, like pull it into your origin, then do the shifting. For example, once you come to your standard format, you'll get your value, that will be nothing but 1 by 2 into 4 into 1 into sinc square omega into 4 by 4. Okay, this is the value that you're going to get. That means nothing but 2 into sinc square omega. This is the value that you're going to get, 2 into sinc square omega for this one. But here, if you do the shifting after in the terms of f of t, if you do the shifting in terms of f of t in order to get this final value, you're going to get the final value I'm writing down here. This is the final expression that you got. Now the final answer will be 2 into sinc square omega into e to the power 2j omega. This is your answer, because after that you need to do the time shifting. Clear? This will be your answer. Do not do it in this way. Do not do it in this way. That is g. First you just take it out like g of t minus 2, whatever the function value, let's g of t. So first don't go it like g of t to g of t minus 2 and convert it from g of t minus 2 to g of t into e to the power minus 2j omega. Just don't do it. It's the wrong way of doing it. Do it in this way. First find it out the standard format, and after finding out the standard format, convert it to your standard form. Okay. Now moving on to the last point. It's a very important point. I want to finish this lecture with this important point. That is your frequency differentiation property. I know the frequency differentiation property says if you have a e to the power minus at into ut, the Fourier transform of this will be nothing but 1 by a plus j omega. But if you multiply t into e to the power minus at into ut, that will be nothing but j into derivative of your f of omega, where f of t is this. So if you are multiplying t to the power n, then this answer will be, what will be the answer? Very, very important observation, a very important question can be asked. Always remember this formula, that will be nothing but n factorial divided by a plus j omega whole to the power n plus 1. Please remember this formula, very, very important. Okay. This we are done with today's lecture. Thank you so much for your patience. If you have any questions, query, feedback or suggestion for this video or this channel, feel free to write it down below in the comment box. And if you want more and more videos like this, give us a thumbs up and do subscribe to our channel GATE ESE Lecture. See you in the next lecture, where we're going to discuss about different questions on duality principle. Okay, till then, bye.